Hello people, welcome back to my channel, TheTalk. Today we are going to look at the real numbers chapter. So we will be looking at a theorem, that is how to prove a number is irrational. So we will start looking at a theorem which proves that root 5 is an irrational number. We begin this proof with an assumption that the opposite is true, that root 5 is rational. So what is a rational number? If a number is rational, it can be expressed in the form of numerator by denominator. So in this case, P is the numerator, Q is the denominator, and denominator is never equal to 0. So if denominator is not equal to 0, it represents a form of a fraction. P and Q are co-primes. So first of all, first condition is that the denominator should not be equal to 0, and the second condition is that P and Q have to be co-primes. What are co-prime numbers? Co-prime numbers are those which do not have any other common factor other than 1. So we assume that root 2 in the form of P by Q, where Q not equal to 0. We will begin this theorem by squaring on both sides, or short form you can say it as SOBS. So hereafter we will be using this word SOBS, which means it is squaring on both sides. So root 2 square equals to P square by Q square. So this implies that 2 equals to P square by Q square, because root 2 multiplied by root 2 is 2. Now upon transposing this Q square in the denominator to the numerator on the other side, it becomes 2Q square equals to P square. There is a theorem that says P is a prime number if P divides Q square, then P also divides Q. That means if P is dividing some square of a number, it also divides the original base. So Q is the base, right? So it also divides Q, where Q is always a positive integer. So considering this statement, we say that P equals to 2a, and from the equation 1, so equation 1 we were left with a condition like 2q square equals to p square. So this was the equation in 1, and when we continue further, this means that if 2 is dividing q square, then 2 also divides q. Putting this in equation 1, so we got that p equals to 2a, so 2q square equals to, when we substitute p equals to 2a, this will become 2q square equals to 2 square is 4, a square. And now q square can be written as 2a square. So 2 is dividing q square, because when you transpose it, it becomes a square equals to q square by 2. This means 2 is dividing q square. So from the theorem that we discussed before, that if any number is dividing square of something, so the base will also be divided by the number. So 2 divides q as well. As 2 is dividing both p and q. So in the first step, q was dividing p. In the second step, it is dividing q. So they both have 2 as a common factor. So 2 is a common factor other than 1. So this contradicts the statement that P and Q can have no common factor other than 1. So they are not co-prime numbers. So our assumption that root 5 is rational is wrong. So therefore root 5 is an irrational number. So this same procedure can be used to find out that any number is irrational. Root 2, root 3, root 7, all these so on can be substituted. So in the place of root 5, you consider root 2 and continue with the same steps to verify and prove that any number is irrational. So I hope you understood how to find out whether a number is irrational or not. Let us look at some of the exercise questions now. So one of the question in the exercise, 3 plus 2 root 5, prove it that it is an irrational number. So we consider this statement for all the proofs, that we begin solving this question assuming that opposite is true. So what is the opposite? 3 plus 2 root 5 is a rational number. So if a number is rational, what happens? P by Q, the numerator by denominator form, and Q is never equal to 0, and P and Q are co-primes. So you know what co-primes are? They do not have any other common factor other than 1. So we will take the first step. So the rational number that is assumed 3 plus 2 root 5 now can be written in the form of p by q. Just as we did in the case of proving that root 5 is irrational, what have we done? We squared the LHS and the right hand side. So when you square it, before that let's transpose everything. Let's only have root 5 on the left side. So root 5 becomes half of, so 3 is adding, so when it goes to the other side it becomes p divided by q minus 3, and 2 divides when it goes to the other side. So this we are going to, now since p and q are integers, we have said that p and q are integers. Obviously when they're integers, whatever expression and whatever numbers you put in this expression, like half of p divided by q minus 3, will definitely be a rational number. That means it will have a finite value, which means root 5 is rational. So because both the quantities have to be equal, right? A rational can never be equal to an irrational number. So if half of p plus q minus 3, if this is a rational number, obviously it is meaning that root 5 is also rational, which is wrong. But this is contradicting a fact that root 5 is rational. So our assumption, like whatever assumption we did in the beginning, that 3 plus 2 root 5 is rational, is wrong. So therefore 3 plus 2 root 5 is an irrational number. So we'll look at one more question. So prove that the following are irrationals. 7 root 5. So we begin with the statement. This is the most important statement for all the questions to prove whether a question is rational or irrational. So you assume the opposite always. You assume that 7 root 5 is a rational number and it can be expressed in the form of p by q, where p and q are co-primes. So co-primes are those who do not have any other common factor than 1. So what do? We consider the first number, that is 7 root 5. 7 root 5 equals to p by q. We transpose it. We only have the number and you transpose it. So it is nothing but multiplied by 7. So the RHS, the right hand side, whatever you're having, is definitely a rational number. That means it's going to get a finite value. Okay, you can express it in the form of p by q because it's done. Whereas, so this proves that if the right hand side is a rational number, it also means that the left hand side is also a rational number. But this is contradicting the fact that root 5 is a rational number. So whatever our assumption we made in the beginning that root 5 is rational is wrong. So therefore 7 root 5 is an irrational number. So you can solve all the exercise questions of this using these statements and these steps that are mentioned in the video. I hope you have found this video on proving a number as irrational or not helpful. So if you have liked the video, please don't forget to subscribe to our channel TheTalk so that you don't miss any updates from us. See you in the other video with an interesting topic. Bye bye.